Okay, and so we'll, I guess I'll just go over it kind of briefly here. There's still a lot more I want to cover. So this is for your final project. It's worth 30% of your grade. And, anytime you have, I don't know how, did you guys, have you taken classes where you have to write essays? Right? Like, those were always my least favorite classes. I mean, no knock on North Campus or anything like that. Just, as far as I was much more of a math and numbers, science, one correct answer type of person. And so, writing essays always felt like the grading was very subjective. I mean, I knew, like, this wasn't that great of a paper. I don't deserve that great of a grade. Or, like, I put a lot of effort in. I hope I get a good grade. And then, it'd come back with a lower grade and I might be surprised or upset. But they said, make a grading rubric, try to be as clear as possible. It's impossible to completely eliminate any subjectivity for some kind of project or essay or something like that, a report. But I did my best to try to explain everything. And so these will kind of be the guidelines. And for each kind of component, I've said, this is what good looks like. This is what a basic submission looks like. And this is what something that needs improvement looks like. And then I put in loose point guidelines here where, I said, if it's good, you probably won't lose any points. But I'm going to give myself a little flexibility with the tilde here by saying, maybe it was good. Maybe something was a little off, so anywhere from 0 to 3-point deduction, okay? Whereas if it falls in kind of the basic category, somewhere probably around 10 points or so, but maybe if it was not that bad, maybe only like 5 points off, or if it was not that great, maybe 15 points off. And if it's like really kind of in this needs improvement category, then you're going to be losing a lot heavier. Not everything is linear, okay? So like here it goes 0, 10, 30, and here it goes 0, -5, -30 or something. So so as far as the selection of data goes, as long as you guys are meeting with me, I think everyone should get kind of good selection of data, unless, maybe I wrote something like team members aren't interested or knowledgeable in the subject, and that could be, a problem. But then, if you just suddenly decide on a whim to change the entire data set without having talked to me, then we're going to have some issues there, okay? But anyway, stuff for like the overall writing of the report, good looks like explanations are correct, complete, and convincing. Assumptions are made explicit and given justification. So anytime you make assumptions, you should justify them. Over here, I've got explanations are partially correct but incomplete or unconvincing. Assumptions are made explicit but not justified. And then and the poor category or needs improvement will be explanations are illogical, incorrect, or incoherent. Assumptions are not made explicit. And so, if it's a little bit of this and a little bit of that or something, then, you're probably going to get deducted something in between. Anyway, you guys can read through all of this. Maybe I'll just go through kind of the good column, and then you can look at the other two columns yourselves. It's quite a long rubric, and it took me quite a long time to make, but I hope the goal of this is to make it clear kind of what I'm expecting for each of these sections and areas of your report, right? So for background information, it should be complete background information relevant for understanding the data is provided. All variables have been described. After reviewing the provided background information, a person not familiar with the subject will be able to understand the significance of each variable in the data. Unnecessary or irrelevant information is not included. As far as the data analysis goes, the motivation, it should be that, analysis follows a theme and is motivated and guided by research questions. I don't just want to have like some arbitrary variable thing analyzed here versus over here or something, okay? Analysis is appropriate to the question, is complete, relevant, and informative. And an interesting finding in one table or graph leads to follow-up questions and analyses. So if you are doing something and you notice something interesting, like you create some kind of histogram and there's some outliers over here, it's worth following up on, okay? It's worth investigating what these outliers are, or if there's some kind of interesting pattern that you notice, that should lead to more questions. This is kind of the process of data analysis and data exploration. And if you're not doing that, your analysis is going to be weaker, okay? As far as exploration of individual variables, I wrote the analysis of individual variables is appropriate and informative. Interesting or unusual features or outliers are explored and given appropriate commentary or treatment. For example, outliers might be removed from the analysis if appropriate. They might be analyzed separately. Maybe no special treatment was deemed necessary. Okay, all of these things should be explored. You don't have to do all of these things, but you should decide one of these things, and you should kind of justify your explanation, right? So some of you are working with really big data sets, like and I'm saying really big is anything that's over kind of like 20,000 or something like that, or even over a few thousand. We're starting to get into the realm of quite big, and so maybe this requires kind of just subsetting certain segments, right? You're going to only look at a certain category or a certain type of variable, or whatever it might be. That should all kind of go into here. A lot of times when you have these massive data sets, if you just aggregate everything all together and you just say, like, let's count how many are in category A and category B and category C, this does not lead to an interesting analysis, okay? Similarly, exploring the relationships between variables, relationships between variables are explored and explained, and the analysis has depth. If appropriate, relationships between variables are explored and explained separately for different categorical groups within the data. And so one example I said is, maybe you're looking at some academic information and you're looking at the relationship between GPA and GRE score, okay? And rather than just doing GPA versus GRE score for the entire data set, maybe you're looking at GPA versus GRE score for, history majors, and GPA versus GRE score for physics majors and for psychology majors, or something like that. You're segmenting the population into, potentially different groups and seeing if there is some kind of relationship there. And the interesting thing will be if the relationship changes from one group to another. Maybe there's a strong correlation between GPA and GRE score for physics majors, but that correlation goes away for history majors. I don't know, okay? But it's kind of the differences between these categorical segments that I think are interesting, okay? That, for one population or one subset of the data, this relationship exists, but for, a different subset, a different relationship exists. I think those kinds of findings are interesting. And those are the types of things that I want to see being explored in your exploratory data analysis. Of course, it's going to depend on the kind of data that you are working with and what kind of things. And so, that's what I'm hoping, when you have your meetings with me, and a lot of you have already had meetings with me, I'm just kind of, I'll often be spitballing and throwing out just a bunch of different ideas for you guys to explore that require kind of these, the depth here, okay? As far as visual presentation goes, what I'm expecting is that plots convey information correctly with adequate and appropriate reference information, and features of the plots are fully explained, okay? What I don't want to see is just you make a plot and that's it, okay? Hoping that the plot explains for itself. Every plot should come with some kind of explanation. And ideally, the plots don't contain unnecessary information. So here, in these examples, I gave kind of, so sometimes people, correlation heat maps aren't my favorite kind of plots, but they certainly can be useful in certain contexts, okay? And so if you have like a ton of variables and you just make a correlation heat map of all the variables, okay, so a correlation heat map, if you're not sure, let's, they look something like this, where kind of dark blue indicates high correlation, and dark red indicates high positive correlation, and dark red indicates high negative correlation, and something close to white indicates like very little correlation. Something like this, right? And if you just throw this on here, for me, this is not useful, right? This is not something that like, what am I supposed to look at here? Okay, what is it that you want to show me? And maybe you can just describe important features here, right? You can tell me things like stroke is not really correlated with anything, right? I don't even know what stroke is. It looks like something about a car, okay? But like, I don't know what. I honestly don't know. Is that like a 4-stroke engine versus how many kinds of engines are there with strokes? I don't know. Probably the reason why there's not much correlation at all here is that probably every single car has like the same kind of stroke. I imagine almost all engines are 4-stroke engines, or something. I don't even know, right? Okay, so something, right? So stroke doesn't correlate much, and whatever. Okay, at least explain something, what I should be looking for, and ideally, if there's just like, if you want to point out the relationship between 4 of the variables, x1 and x2 and x3 and x4 or something, ideally you would limit your heat map to just those 4 variables and really just emphasize the important relationship that exists between those 4 variables, and not bog it down with all of the other things that aren't important if those things aren't. Maybe everything is important and you want to talk about every single relationship that's in the heat map. But the idea is, don't just make a plot and say, ooh, there you go, okay? Everything should be explained. There should be a reason. Like, if you're going to include a plot, a question you should ask yourself is, does the inclusion of this plot make my report better, okay? And if the answer is no, don't put it in there, okay? Right, it's kind of every decision you make, right? You should have some kind of long-term goal, and it should be like, is this decision going to help me achieve that long-term goal in life? And if the answer is no, maybe you shouldn't make that decision, right? But I don't know, that's something entirely different. But anyway, and then as far as the modeling goes, okay, so the EDA is the most important part, and then the modeling, is also important, but is I would say the EDA is the most important part, okay? I'm looking for a model that's relevant to the theme and the research questions, right? An appropriate response variable is selected. If you're trying to predict something or gain insight on some variable, pick the right one, okay? And then appropriate variables with potential relationships identified in the exploratory analysis are the ones that are used and included in the model, okay? I don't know, depending on the model, you might want to just dump all the variables in there, okay? But rarely, I would say it's not often the case where just straight dumping all the variables in there is the best strategy, okay? So that's just something to consider. If necessary, you're making new variables or features, right? So maybe you're going to make a new variable based on some other variable, or maybe you're going to group some of your. Maybe there's a categorical variable that's already in your data set, but it has like too many categories, and you're going to group them in logical kind of groups, right? So maybe you have like country, and there's so many, and maybe it requires you to create another group for like continent or region, where you're grouping some of these things, and that emphasize. So that would be some kind of thing where you're creating a new feature, a new variable. This might have happened earlier in the exploratory data analysis, okay? So, some of these things, there's a little bit of overlap, and the boundaries of such aren't entirely clear, okay? And then as far as the data modeling goes, in the I think in the project guidelines, I said groups have two choices. Okay, they can either choose to model for the purpose of prediction or model for the purpose of insight. Okay, most groups go for prediction, but insight would be something where you're picking, like, generally for insight, you're going to be picking some kind of regression, linear or a simple regression model where the coefficients carry meaning, right? So the nice thing about a linear regression model is that each coefficient has meaning and interpretation, and it helps you understand the relationships between these variables. Things like when determining the price of the house, each square foot I add increases the value of the house by $100 or something like that. That's an insightful relationship, okay? Maybe the prediction performance isn't the greatest, but as far as overall, that's kind of the relationship that you observe. That's fine. On the other hand, you might do some kind of model where the only purpose is prediction. And these would be things that are a little bit more of these black box models, like random forest or neural networks or whatever it might be. Something where you don't have a clear understanding of how these decisions are made. That's also fine, but you should be evaluating kind of the predictive performance, right? So the prediction performance is evaluated correctly. If it's classification, you're looking at things like precision and recall. If it's regression, you're looking at root mean squared error or whatever it is that you're using to evaluate performance. And any potential improvements are identified and discussed and acted upon if appropriate for prediction. As far as the insight goes, if you're gonna use your model for insight, then you really need to check kind of the assumptions regarding the suitability of the model. If you're doing a linear regression, one of those assumptions is constant variance and things like that. And all of those things are checked. Probably different potential models should be considered and compared, and the merits of these different models are discussed. Okay, so different models being like, linear regression could just be, comparison models could be like, here's a model with 4 variables. Here's a model where we included a 5th variable. Okay, let's compare this 4 variable versus 5 variable model and see how they perform and relative the merits relative to each other. Okay, it doesn't have to be like I did a linear regression model over here and I've done some complicated random forest model over here. Okay, it just could, the different models could be as simple as I'm including this variable and I'm not including this variable. Okay, but I do want some kind of thought process going into it. I don't want just let's dump all the variables in here and see what happens at the end. Okay, it should be, if you're going to dump all the variables, at least compare it to, how does this model perform versus another model where I was a little bit more selective on the variables that I've chosen. Okay, and then finally, some stuff about the presentation. It should look like you at least practiced a little bit before you came and presented to me. Okay, and not. I didn't put this here because it doesn't matter. It's not going to affect your score. But I do want to say not everyone has to speak during the presentation. Okay, it's a 5-minute to 7-minute presentation. You don't have to have one person speak and then somebody speak for 1 minute and another person speak for a minute and another person speak for 1 minute. It doesn't have to be that way. Okay, if one person wants to do the whole thing, that's fine. If 2 people want to do it, that's also fine. But that person, as far as the presentation portion, that person or those people are carrying the weight of that section. I will ask what each person's contribution to the report was. Okay, and if I have questions during that report, I will ask the designated person, questions about their section or whatever. or if you worked on the whole thing together as a team, then that's great. Then I should be able to ask any of the team members any question from the report. Okay. Is this okay regarding the rubric? And does this make clear expectations, clear what my expectations are for the project and how you'll be evaluated? Okay, and then you can read the other columns and decide, whether your thing fits or doesn't fit, and things like that. Okay. I anticipate most people will get good and basic in most of their things. Okay, and needs improvement is really kind of like, don't do that. If you get all needs improvement, you're gonna fail the project. Okay, so these the needs improvements are docked quite heavily in comparison to the other ones. So so that's what we have. Okay, and as always, you can always kind of post questions as come to office hours. I know in kind of a lot of these group meetings that we have, I'm throwing a ton of ideas, and or maybe not a ton, but several ideas that you want to explore, and I'll try to make myself, if my scheduled office hours aren't convenient, you could schedule other appointments, and we can talk about your progress on the project and ideas and things, questions that you have. Okay. And I know a lot of you, for your initial exploration, you're working with R and Excel, which is fine for now. But my encouragement is that when you really, in earnest, begin working on the project and stuff, really force yourself to use Python. You're going to be way slower, and it's going to be frustrating, okay? Because you're not familiar with Python. But the whole point of this class was for you to gain familiarity with Python. So force yourself to do what's hard, and as I always like to tell my own children, when it's hard, it means your brain is working hard, right? So and that's how we learn, and that's how we grow and improve. So if you only stick to what's easy to you, we don't really improve. So okay, let's talk about today's stuff, which is going to be an intro to Matplotlib. Lib? I don't know. It's Matplot library, and it gets its name from the person who created the library was trying to adapt MATLAB's plotting abilities. Okay, and so MATLAB has a certain notation and whatnot as far as making plots go, and that's what they were trying to do. My personal opinion, ggplot is awesome, and Matplotlib is just okay. But there's a few things where Pandas has integrated Matplotlib and made certain things easy, but a lot of other things you got to jump through several hoops. Okay, that's my opinion. Okay, like everything else that we're doing in the class, you can go online, type in Matplotlib, and then you can say like make histogram, right? You type whatever it is that you're trying to do, and then and generally the documentation for how to do it will come up. The other part is you can always just go to the Matplotlib website and look at examples or tutorials, and when you look at the examples, you can say like, oh yeah, this is the thing I want to create. Okay, so you're gonna come here and you'll see kind of the example code, right? A lot of these examples are very like this is the documentation. This is the plot you want. This is the code that you type in, and you're going to be looking at each of these things, and you'll say, oh, okay, the thing I want to do is, I want to do plt.bar. Let's look at the documentation for that, right? And then everything, you'll just be searching Google. That's pretty much our lives as kind of data analysts and stuff. How do I do something? Let's look it up on Google. At least that's where we are in the intro course, right? If I would love, right now we have like a whole bunch of classes on R. You have stats 20, and then you move up to stats 102A and whatever. Right now we only have this class on Python. I don't know if we'll ever have like a more advanced Python. Okay, by the time you're in the more advanced Python, a lot of this stuff should be internalized, where you don't have to look up every single thing, right? If you have to look up how to make a bar plot every single time on matplotlib, you're gonna be slow, right? And if we're gonna make a hiring decision, we're gonna go with the person who doesn't have to look up everything online. Okay. But anyway, this is what we do. We're gonna just start by importing NumPy, and then the library that we're using is matplotlib .pyplot as PLT, and this is kind of our convention as far as we go. And then we'll start something real easy. Okay, so what does NumPy linspace do? What does this code do? 0 numpy and numpy pi times 2 500. What is this most similar to in R? It's mostly like sequence. Okay, so in R you can create a sequence going from 0 to 2 pi, and you can specify how long the output you want to be. Okay, so in this, basically we're saying I want a sequence that's linearly spaced, where everything is evenly spaced. Okay, the other is like log space. Okay, but this one we want it evenly spaced from 0 to 2 pi, and we want 500 of these steps. Okay, so that's what this is going to do. And then y is now going to calculate the sine of everything from 0 to 2 pi, right? And so the sine function starts at 0, and as you go up to pi half, you're at the max of 1, and then at pi, you're back at 0, and at 3 halves pi, you're at -1, and back at 2 pi, you're at 0 again, right? And so we'll do that, and then now we create a plot, okay? So, so there's a few things. I could just do plt plot and plt show. Actually, I think in Jupyter, I can just do plt plot, and I think it will make the plot, okay? But to kind of improve this, I'm going to add things like a title, okay? And I get sine of x here. I can, I think the xlim is already kind of 0 to 2 pi, but I'll go ahead and, oh, I'm sorry, I guess the xlim is not perfectly that. It gives us a little bit of edge on the 0 side and the positive side, okay? And so including the xlim makes the graph going basically from 0 to 2 pi here. And then plt.show is kind of the command we use to get the plot to show. I think in Jupyter it automatically kind of shows the plots, but in other, like if you're working just directly from the IPython console or something like that, you generally have to call plt.show. Okay, so this is what we get here. So that's that. Over here I've got a range 051. What is this going to produce? Zero, 1, 2, 3, 4, right? And then here, what does random rand int 0, 10, 5 do? random integers between 0 and 9, and we're going to get 5 of them, okay? And so here, along the x, I'm going to have 5 values, and then in the y, I'm going to also have 5 values, but they're randomly selected from 0 to 9. And then plt.plot, by default, will connect all of these things. And so, x is 0, 1, 2, 3, 4, and then y is just these random integers, and it just connects them. And I happen to just get 9, 3, 8, 4, 7, okay? If this is not what we want, if we want a scatter plot, then we have to call plt.scatter, okay? So plot connects the things by default, and scatter will create a scatter plot accordingly, okay? This is, how do you know that this is plot and that this is scatter? This is just vocabulary, okay? You just have to kind of learn these things. And again, like anything else, in the beginning, you'll probably be Googling matplotlib, how do I make a scatter plot? And then eventually you'll start to remember the more and more you do it. But it's just kind of like, when you took Spanish class or whatever, you had to remember that, I don't know, library was biblioteca. You're going to have to remember scatter plot is scatter and, this and that, okay? So this is just vocabulary. You just got to kind of remember these things, okay? Histograms is plt.hist. And this is always the part that, like, my brain just confuses it always, is that in matplotlib, we call bins equals 30, and in R, what is the argument that we use? Breaks, right? Breaks equals 30, and something like that. And I'm always constantly getting it wrong. This, like, for whatever reason, my brain has just categorized these two words as being synonyms, and I'm always messing that up. But anyway, I think these commands are fairly easy to work with, right? It's not too hard. The hardest thing with all of this is just learning the vocabulary and remembering, not getting bogged down. So here, I'm going to take kind of the same x that goes from 0 to 2 pi, and then I'm going to make 3 sequences, or 3 arrays. One is the sine, z is the tangent, and w is the cosine. And then in here, I can plot, you can do plt.plot. So if I just do plot xy, we'll get that in blue. And if I do plot xz in red, I get this. And so, here it's just kind of plotting them on top of each other, okay? And unfortunately, because the tangent at pi halves and 3 halves pi go off to infinity and negative infinity, we lose any subtlety, right? Like the sine is limited between 0 and 1, but on the scale of going to infinity and negative infinity, and here it actually only goes to negative 300 and positive 300, we lose any kind of information. So here I can plot sine versus cosine. This looks nice. And all of these things, I don't remember. You have different colors. You can type in matplotlib color names, okay? And these are the named colors that you can use. I don't remember, I generally stick to primary colors. Those are generally easy to remember. Blue and like orange, I guess that's a secondary color. Those are easy. But yeah, you've got all of these other things, right? Dark olive green, okay? And I if you closed my eyes, or if you blindfolded me and asked me which color is I don't know, corn silk, I don't think what is old lace, right? Like I don't even know. I couldn't identify that on a chart. Oh yes, I just bought some paint to paint my walls old lace. That's great. Okay. It always makes me happy that Dodger Blue shows up in a lot of these color names. You don't see like Navajo White. What does that mean? I don't know, right? Okay. Well, anyway, this is what we've got. So you have stuff like this. You can. What if I wanted to just reduce the limits of this thing? What would I do, right? So you can just say like you can do matplotlib, y limits, right? And then it's going to be like plt y lim, okay? And you can go, oh yeah, this is what I want, right? And then say you do plt, y lim. So for here, I can do something like plt.ylim, and we'll go from like -4 to 4, and then now we get a plot that seems reasonable to look at. So this is kind of how matplotlib works. Is you kind of so in R, when you call it like your base R plotting function, you kind of give all the arguments all at once. And then matplotlib, it's kind of just like you give it sequential things, and each time you give it some instructions, it kind of it basically creates a plot in memory, and every time you give it additional instructions, it's modifying that plot in memory. And then finally, when you call plot show, it's going to show kind of the results of these things here. Okay. Look at this notebook and just play around with it and see if you can kind of customize things, right? Okay. You have something called subplots, okay? And what a subplot is it allows you to kind of create a grid of plots, okay? And so it starts off, if you do subplot 2, 2, okay, this means I want to create two rows and 2 columns, okay? And this is like the worst part, is that MATLAB has 1-based indexing, and Python has 0-based indexing. But when you're using matplotlib and you use stuff like subplot, it starts with the 1-base index. Okay, so what this is going to do is it's going to create a grid, a 2x2 grid of plots. Okay, so it's kind of, in R you have like par mf row 2 2. In matplotlib you say subplot 2 2. And then this says in memory, create a thing where you're going to have a total of 4 plots. And then we write plt subplot 2 2 1. And that says, okay, and in the first plot, which is going to be the top left, graph sine of x. And then in the next one, which will be the upper right, so it starts in this corner and it goes to over here and then over here and over here, plot plot the cosine. Subplot 3 will be tangent x, and then you can do like subplot 4, and you'll get this. Okay, so now we got sine, cosine, and then if I wanted to, I could do like plt dot subplot 2 2 4, which will be we'll do plt plot x. We'll do x and y color. I think no. We're going to do red and plt dot plot x and z blue or something like that. And then, oh no, I didn't want z, I want w or something, right? Oh, and I should have put it in a title. Sine and cosine or something like that, okay? And it kind of creates the grid of 4 plots, okay? And you can look up subplot online to get the guidelines regarding, how do I space these things out more and stuff like that. But subplot allows you to kind of create a grid of these plots here, okay? I think you've already seen a lot of this stuff, right? So changing the labels and axis limits, this is it's pretty actually easy to do, okay? So you start off with your plot, then you add things like the title and the X label and the Y label, You can change the x limits. Axis equal will be like aspect ratio, so you have even 1-to-1 aspect ratio, things like that. So here, you know, this one will just label your axes and your title. This one, you know, changes the aspect ratio so it looks, I don't know, if you plotted a circle, it would look like a circle and stuff like that. You know, you know, as far as scatter plots go, you can you have these options for the markers. Okay, so this is kind of like your plotting character. Do you want circles? Do you want diamonds? Do you want whatever? Okay, so a lot of again, you can just do matplotlib scatter plot markers. Okay. And these are kind of the different shapes you can do. So, but in general, you have the point, okay, or you could do the circle. You could have up, down, left, right triangles, and I don't know what these things are, but there's something else, okay, and octagons. And honestly, if you're going to use an octagon, don't use a circle at the same time because nobody can tell the difference, right? And you know, I don't know. You've got two kinds of hexagons. Hexagons where the flat side is on the bottom and hexagons where the flat side is vertical. I think these are like really hard to tell apart, but whatever, you can do this. And so here I'm going to do some scatter plots of, I think D is diamond and H is hexagons. Is that right? H is hexagon, capital H is hexagon 2, and D is thin diamonds. Okay. And I've chosen names like maroon and dark slate gray, just for fun. Okay. And you get these shapes. Okay. We have a few things that will do like two-dimensional functions, and this is mostly just to kind of show off. I mean, I shouldn't say that. Like they can be useful, right? So so here we've got like a mesh grid. Okay, so when you do X and Y, it's basically taking the result. So X has a length of 3 and Y has a length of 4. So the result's going to be kind of a 4x3 grid, and you end up presenting this. So mesh grid XY. For X, we'll get this, and if I print Y, you get kind of the opposite, right? So here we're repeating 0, 1, 2. We're basically broadcasting it. So it's going to be 4x3, and we're broadcasting Y so that it gets broadcast the other way. Okay, I guess I did the print Y in the following thing. Okay, so there's mesh grid X. Here's Y. Okay, and then what we can do is we can create like a function that's just going to return X and Y, and we'll apply that to the mesh grids X and Y. Okay, and so this will create kind of the product of X and Y. So I'm just doing element wise, what's the product of 0 times -1? What's the product of 1 times -1? What's the product of 2 times -1? And this is how we get that top row, and we do this for this whole thing. Okay, so why am I bothering with this? Well, I start off with this 4x3 example to show a simple case of this thing, and we're going to just kind of expand it to be, you know, a little bit more complex, where we're going from -3 to 3. And then what does this look like? exp to the x squared times exp to the negative x squared times the exp to the negative y squared. What's that going to result in? I'm missing a few constants. But anytime you have exponential to a negative quadratic, the shape of that thing is going to be... Nobody? So exponential to a negative quadratic is what basically defines a Gaussian, right? So your Gaussian, your normal distribution curve. So if we look at the normal distribution, all it is, okay, it looks like this, and maybe none of you, maybe you have this memorized or maybe not. This part's just a constant, okay? If you treat sigma as a constant, this part's a constant, and over here you've got basically x squared, some kind of quadratic, right? It's a function of x squared negative x squared times some other constants. Okay, so we're just all that we're doing is we're just kind of shifting the location of that upside down parabola. And so basically I've got a Gaussian times a Gaussian, and these are treated independently. So what is the result gonna look like? It's going to look like a multivariate Gaussian, okay? Multivariate Gaussian, and there's no covariance between the two. And because both of them are x squared and y squared, they're both having the scale thing, it's going to be, they're going to have the same kind of variance in the x direction, the same kind of variance in the y direction. So it's going to look like a circle, concentric circles. So just imagine you take your Gaussian curve and you spin it around and you get like this perfectly rounded out. So, you take your Gaussian PDF, this thing, and you're just spinning it around to kind of make this smoothed out cone shape. Okay, so that's what we're doing here. And that's what Z will do. And now we can plot the contours of this. Okay, and that's exactly what we get. You can do something like image show, and this kind of makes a colorized version of the thing. But this thing represents your basically a multivariate normal distribution, where it's basically it looks like this in one direction and it looks like that in the other y direction as well, right? And I could change this so that it's not x squared, but it's like 0.5 x squared. Okay, whoops, I'm missing a star there. Okay, so if I do that, suddenly now I have some variance in the other direction, right? So because I'm just doing a product, it's still going to be independent, and so our things will still be kind of perpendicular, but it's basically going to be kind of this normal Gaussian stuff. Okay, so this is just a simple introduction to Matplotlib. I would say just kind of play around with it, see if you can make your own plots, see how much of this vocabulary you can start to learn and internalize without having to constantly refer back to. Make your own cheat sheet, or find a cheat sheet online that's helpful for Matplotlib. Okay, well, we'll end there. We'll see you guys on Friday.